Hey there, folks. So this is the start to Module 1, which is one-dimensional kinematics. And so all one-dimensional kinematics is motion along a straight line. We don't worry about how the motion started or why the motion is continuing. All we really care about is describing what that motion is. What's its speed or velocity? What's its acceleration during this time? How much has it moved? What's the total distance has it gone? So we're going to be dealing with these quantities of velocity, speed, acceleration, displacement, distance traveled to help describe this motion along a straight line and give it a picture to some sort of physical motion. So the question you may be asking yourself right now is, does this one-dimensional motion or motion along a straight line even happen in real life? So the answer to that is yes. One of the examples is in sports, and I just have this example of somebody hitting a golf ball into a hole, but it can be applied to a bunch of other sports. So soccer, for example, if I were to pass a ball to a friend along the grass, that's one-dimensional motion. If I am playing American football, if I'm running the football down the field, that's going to be one-dimensional motion and can be described using one-dimensional kinematics. If I go to jump up and dunk a basketball, that's going to be one-dimensional kinematics, just in a different direction. And then with swimming, you can swim in a swimming pool, and that's going to be, again, described by one-dimensional kinematics. Something that we see probably more frequently in our everyday lives is when we're walking or we're driving and we're using a map app or a GPS to get an estimate on the amount of time it's going to take. We have one-dimensional kinematics to thank for the ability to be able to estimate that time. So we relate how fast we're walking or how fast we're driving, and how far we have to go to give an estimate of the time that it takes for that motion to happen, which is all going to be things that we're going to be dealing with in one-dimensional kinematics. And then finally, as just another example, we see it in nature as well. So birds flying or animals moving. We've got fish swimming or whales swimming. All those motions can be broken up into motion in one dimension, and that can be described using 1D kinematics. Closer to us, in terms of biology, we have blood flowing through arteries. That motion can be described using one-dimensional kinematics as long as we break it up into certain parts. And so as you're going through the module and as you're learning these concepts that are involved with one-dimensional kinematics, start to look around you and try and relate those concepts to things that you see and that you've experienced in your everyday life to help it make give it a little more context and make it more concrete as well. So here I have the learning objectives listed for Module 1s. So by the end of the module, you'll be able to achieve all of these things that we have outlined. And what you want to do at the end of the module is come back and take a look at each of these things. And so ask yourself, let's just take one for example, can I explain the difference between velocity and acceleration? If the answer is yes, then great, move on to the next one. Make sure that you can do that as well. If you're a little unsure, then go back into the note packet or go back into the textbook and just refresh your memory on what the difference is, so that you can explain it well enough to somebody else. If you can do that, then you should be good for the exam, should be good for the homeworks and the quizzes. coming up, because all of these concepts build on one another. So we want to make sure you have a good starting foundation for when we move on to the next module. In the next part of this video, we're going to look at a position versus time graph and try and relate some of the features that we see in a position versus time graph to something that's happening physically. So this simulation is called a moving man simulation, and you're actually going to be using it in part of the lab in module 2. So it'll be good to just get some experience of what this simulation is and what kind of features it has. And so what we have is the ability to move this man around, and we can create a position versus time graph. So positions on the y-axis, and then time is on the x-axis. So I'm going to click record right now. And we see that the man is stationary. And what we have is just a horizontal line. So as time's moving forward, nothing is happening to the position of the man. Now let's see what happens when I decide to move the man. So I'm going to move the man to the right at a constant speed. So as I'm moving the man to the right, the graph changed from a horizontal line to a diagonal line that's pointing up. And then as I stop again, the man is not moving and the graph is a horizontal line. So now I'm going to move back at a constant speed and stop at the same position. So now we had a diagonal line again that was roughly the same size or same shape as when I moved to the right. And then when the man stopped, we had a horizontal line again. So what's the next thing I want to look at is what's the difference between when the man moved to the right and when the man moved to the left in terms of this graph. With this graph, pointing upwards was when we moved to the right, and then pointing downwards was when we moved to the left. So when we're moving to the right, we have a positive slope. Remember, slope is just the rise over run of a graph. So the change in y over change in x. And then when we're moving to the left, we have a negative slope. And now that relates to the direction that we've chosen. So to the right is positive, to the left is negative. So the slope of the graph, the sign of the slope of the graph tells you information about the direction. So the last thing, we're going to move the man to the right, and we're going to do it at different speeds. So I'm going to start off as a slow speed. So he's moving to the right, and I'm going to stop for a second. Then I'll move to the right at a faster speed. And then I'm going to make the man run to the end. So we can stop this here and talk for a second. The steepness of the slope, so how much it is from the horizontal, tells you something about the speed. So as the man is moving faster and faster, the steepness of the slope is getting greater and greater. And so these are concepts that you're going to explore more throughout the module, but this should give you a little flavor of different components that you can look for in a graph and how they relate to actual motion.